And we're back in better than ever. We're still in 12.3 where we're discussing limiting reagents and percent yield. In the first podcast, we took a look at the idea of a limiting reactant or reagent, where it's the reactant or reagent that runs out first, controls how much product can be formed, and then the other reactants would be considered in excess, and you're going to have some of that left over. So let's see how this plays out in an actual chemical reaction. So let's say that we have, let's get our pen ready here. Let's say that we have 100 grams of copper reacting with 100 grams of sulfur in the following reaction, where you take copper metal, sulfur metal, and it combines to form copper 1 sulfide. Now, the questions are, what are the limiting and excess reactants? On the next page, we're going to be taking a look at how much of the product can form, and then the last one, how much excess reactant would be left over. So let's go ahead and work through these questions. Now, just like we did above, and let's kind of slide up above here, with our sandwiches, we simply took each of our reactants or ingredients and figured out how much product could be made, and then the least amount that could be made, that's actually what you're going to be looking for. And so we're going to do the same thing here, where we're going to start with 100 grams of copper metal and 100 grams of our sulfur, and we're going to calculate how much of our product can be made and then compare. So let's do the copper first. We are in grams. We need to first get that into what? Into moles. 1 mole of copper, using our molar roadmap in our periodic table. 1 mole of copper has a mass of 63.55 grams, so that the grams of copper divide out. Now we need to use our mole ratio, where we're going to go from moles of copper over to moles of our product, which in this case is 1 if it's not there. So the mole ratio is going to be 1 mole of our product, Cu2S, over 2 moles of our copper. 2 moles of copper will form 1 mole of our product. The moles of copper divide out top and bottom. And it looks like we're going to be looking for the mass of this solid. And so we'll go ahead and multiply by the molar mass. Now the molar mass of our product here, we just got to sketch off to the side. We have 2 coppers at 63.55. We have 1 sulfur at 32.07, and when you add those up, multiply and add them up, I get 159.17 grams per mole as the molar mass. So we'll go ahead and multiply this then by 159.17 grams of our product per 1 mole of product, so that the moles of Cu2S divide out top and bottom. We are left with grams of Cu2S, and when you perform that calculation, 100 divided by 63.55 divided by 2 times 159.17, of course I left off the multiplying by ones and dividing by ones, and when you perform that calculation, I'm getting 125.2 grams of copper 1 sulfide that could form from 100 grams of copper. Now, does this mean that that's the amount that's going to be formed? No. We have to take a look at how much the sulfur can produce. So now we'll do the same thing with that. Let's go ahead and change the grams of sulfur into moles. So 1 mole of sulfur has a mass of 32.07 grams. The grams of sulfur divide out top and bottom. We'll use the mole ratio now to change from moles of sulfur, which is 1, to moles of product, which is also 1, so it's a 1-to-1 ratio. 1 mole of Cu2S over 1 mole of S. Now the next question would be, well, do you actually have to put that fraction in there if it's just 1 over 1? The answer is yeah, you want to do that, because when you do look back on your work, you want to make sure that you just didn't simply forget about the mole ratio. You can quickly look at it and say, yeah, I've looked at it and it is a 1-to-1. So you don't make the mistake of just forgetting it and it might not be a 1-to-1. And now that we're in moles of product, we're going to multiply by the molar mass to get it into grams of product. We've already calculated this molar mass, so we're good with that. And so we divide out the moles of Cu2S, perform the calculation, 100 divided by 32.07 times 159.17, and I'm getting 496.3 grams of Cu2S. So 100 grams of sulfur can produce almost 500 grams of our product. The 100 grams of copper can only produce about 125 grams of our product. So this is the amount of product that you would expect to form. Why? Because at that point the copper runs out. It is the limiting reactant or reagent. That means that the sulfur is in excess. We're going to have leftover sulfur. So the first question simply asks, what are the limiting and excess reactants? Well, there you go. Copper is limiting, sulfur is in excess. Now the next question, as you flip over to the other side, it says, what mass in grams of Cu2S could form? Well, again, it's the copper that controls this reaction. It's going to be the 125.2 grams that could form. We say could because down the road we're going to show you why that might not form, but for right now, theoretically that could form. You can't get to the 496 because you don't have enough copper. And now the last question says how much excess reactant would be left over. Okay, so now here's what you want to do with this. We take our copper, our 100 grams. We know we need to use all of that. We're going to calculate how much of the sulfur that we need. It's not going to be the full 100. You're not going to need all of that. So let's calculate how much sulfur that we need and then subtract that out from what we have. Alright, so let's go ahead and do that. Scrolling on down. We start off with 100 grams of copper. We use our mole ratio, our molar mass to change it into change it into moles. Everything gets changed into moles. 63.55 grams per mole. So our grams of copper divide out. Now the mole ratio in this case, if you flip back to the previous page, is 1 mole of sulfur is needed for every 2 moles of copper. Why? Because you're going to need it's Cu2S. And if you scroll back up, the mole ratio is a 1 to 2 or 2 to 1. Alright? So that's what we're going to use there. Our moles of copper divide out, top and bottom. We're into moles of sulfur. We're going to change that into grams, 32.07 grams of sulfur per 1 mole of sulfur, right off the periodic table. And when you perform that calculation, 100 divided by 63.55 divided by 2 times 32.07, it looks like we're going to get 25.23 grams of sulfur needed. Now, how many grams of sulfur do we have? Well, we started with 100. We have 100 grams of sulfur available. So if you have 100 available, you only need 25.23. If you subtract those two, you're going to have 74.77 grams of sulfur left over. So stoichiometry, limiting reactants, is the exact same thing as what we learned in 12.2, where you're simply doing a couple of extra calculations to figure out which one is limiting and which one is in excess. And then you can do a third calculation to figure out how much of your excess reactant that you actually need, subtract that from what you have to find out what is left over. All right? In the next podcast, we're going to take a look at the reaction where iron gets rusted. We'll see you next time.